All right, class. This is gonna be one of several videos I make. And I do plan on uploading them to YouTube. So, if you're interested in watching them there, let me know. Share my screen. Okay. So first things first, because I didn't really get to go over this in class, or maybe I did, I forgot. I want to show you just how to access the homework system, and you don't have to pay for it right away. There is an option to get temporary access, and I'll try to explain how to do that, although I can't see that option as I go through it. So if you're unsure, just let me know, and I'm happy to show you. Okay, so there's really two ways to access the homework questions, okay? The first way is this, either in modules or in assignments. You click on the specific homework assignment, um, and what that does is it's going to take you to Pearson, but there's a big difference between that way and the other way that I'm going to show you, okay? So if you click this one, uh, that that takes us to Pearson, just like the other way will. There's one major hold up by doing it this way. And that is, once this loads, geez, it's a little slow, a little slow. By the way, it's not my internet. Pearson can be wonky, at least this past week it has been. Let's see. Okay, if this ever loads, geez, this is not good. Tech difficulties. Sorry, guys, for the first video you're watching. Okay, there's a difficulty. Let's see. Let's try to go directly to Pearson. So this is the other way. So that is one way. The downside of that way is that once you get into Pearson, you can only work on the homework itself. You can't access um, the additional resources that Pearson has. Um, so the best way is always, no matter what, go to access Pearson. Hopefully this is going to get us through. Maybe not. Okay, yeah, that way works. That's good. Okay, then you click Open My Lab and Mastering. Um, it's a little slow, but we'll get there. Okay. So once you're in here, you're going to see all these other options, and I'll try to explain as much as I can from there, but you can explore as well what you see. You might see a couple of different items that I don't have, or vice versa. Some of these items might not be available to you for obvious reasons. And once you're here, the basic is go to homework assignments. Okay? And these are the ones we have right now. Uh, And you can see the due dates, you can see the assignments, okay? And they should be sequentially ordered. So right now we're in chapter 1, and we're going to go over these topics, okay? So you would just click on homework, and it's going to take you to a new window, and that's it. And that's how you're going to be doing most of the class. But I want to show you a couple of the other side features here before we jump into that, okay? The main thing would be the e-text, right? So when you purchase this course, you're going to get an ebook, right? And with that ebook, it's like having the physical book, um, but you don't actually have it, right? It's a virtual book. So you click that, and it's pretty straightforward from here, but I'll just show you like a couple features in the book. Um, Table of contents. So this is just all the chapters, just like a table of contents is in a regular book. But if you want to go through examples and read and see other exercises, this is how you would do it. Over here, if you click table of contents, you have your chapters and all the material. I want to make this clear from day one. All the material that we're going through is from this book. Okay, so these are the authors, Roxwell, Krieger. Okay, so if you're wondering like where are these problems coming from, every single problem is straight from this book. and it's available in physical form if you go to the bookstore, buy it. But once you pay for the MyLab Math, which I'll talk about more, um, you have access to the ebook. Now, going back real quick, for those of you guys accessing this for your first time, notice how smoothly once I went to access Pearson, I clicked open my lab. It just took me right to the homework. For you guys, there is going to be a screen that pops up and it's going to be asking you to pay right away and say, pay this amount, pay this amount. If you already have an access code over on the left side of the screen when you're at that window, it'll say enter access code. So you can do that. And then at the bottom, if you scroll all the way down, there'll also be a hyperlink. And at that hyperlink, if you click it, there's something that says temporary or trial access. Definitely do that if you don't have the money right now. It'll work for 14 days, I believe. If you have any issues with it, let me know. Okay. So that's that. Okay, so the ebook is there. We also, with using Pearson, we have multimedia library, and this might be what some of you guys are looking for, right? It's going to have PowerPoints, activities, animation, videos, all sorts of stuff to help you. So, um, so in this video, I'm doing chapter 1, right? What section? Let's say 1.1. I want to select all of these just to see what resources are there, right? Scroll down and we have animation. We have the textbook itself. We have videos. We have test prep videos, and we have PowerPoint. So most likely, you guys, if you want something to follow along as you work through the course, you're going to want to click on this PowerPoint. And yeah, sorry, it's a little slow, but you can edit these as well. This one only has this section, right? It's not the whole chapters, it's just section 1.1 has 15 PowerPoints. Okay. And I could make videos on how to use these, but I'm gonna sort of do my own thing here. Um, so yeah, follow along with these if you want some sort of supplemental stuff to guide you through each section. And then try the homework after that, right? The other option, like I said, is you can go into the book, read each section, and then do the work. Okay. But knowing students as I do quite well by now, that's probably not how anyone's going to do this, right? Most likely, all of you guys are going to go to homework, and that's fine. I'm not saying this is good or bad. I'm leaving that to you. You guys are adults. But you click on assignments and and you have this is a lot of questions, but it's opening ones, so there's not that bad. You guys are going to go problem by problem most likely, and then just try them, trial and error. That's my guess, and that's fine. If that's your learning style, that's totally fine. But you're not alone. If you do that strategy, problem to problem, you're going to have help, and I want to explain the help briefly. So this is the first question in the first assignment of the whole course, and it's asking us to simplify fraction 18 over 90. And let's say we don't know how to do that. That's totally fine. This is not actually an easy problem. Okay. Um, what we could do, or we could try it, right? But let's say we don't know what to do at all. Down here, and most problems in the homework for the entire course are going to have these buttons. Help me solve this, view an example, and this get more help. In this particular problem, there's a video I could watch, right? I click video, and it's sort of like superfluous because I'm making a video to help, but this video would basically walk you through how to do this problem. Okay, so sometimes they have videos, sometimes they don't. Click the textbook button, that's going to take you to the textbook. You're probably never going to use textbook because it doesn't take you anywhere specific. It just takes you to the section you're in. So if I did this, it would probably take me, if you see up here, it tells me which section this is from. This is from 1.2. It's going to take me to section 1.2 if I open the textbook. That may or may not help, right? Then I have to search for an example, so on. But that doesn't mean we're alone. Like this one has a video, but if it didn't, we still have these two buttons, and they're similar but different, right? So you need to know right off the bat what they have in common and what's different about them. Okay. Um, View an example. If I click that, it's going to take me to a similar problem, right? You see the problem that I started with that I was supposed to answer here was simplify 18 over 90. But now in this example, this is supposedly going to help me. I have 20 over 100, and it tells me how many steps to this problem. There's 4, and I'm supposed to follow how they do this one, all 4 steps, right? I click continue, continue, and you can print these out if you want. And it arrives at an answer. Now, this answer, 1/5, it was a simplification of 20 over 100, is not most likely not the same as if I simplified this. This is a similar problem. So this is really trying to solve by using a similar problem. But notice once I close that, let's say I followed what they did, I got how they solved theirs, then I'm able to solve mine. I get my answer. Okay, help worked. It worked. But there's times when it doesn't. There is a more thorough version that's help me solve this. Okay. Notice when I click help me solve this, it's the same exact problem. And you might be thinking, okay, well, I'm never going to use view an example because help me solve this is so good. Why would I need view an example if help me solve this works? Well, here's the catch, and I'll show you. Um, Number one thing is help me solve this. Every step, it's going to ask you to like enter something for most of the steps. So it's going to tell us, it's going to see if you're following, right? And it will, after all these steps are completed and we've entered stuff, it's going to give us the right answer to the problem with one catch, right? So this is the difference. Help me solve this once I'm through with that. So I do this. 18 is 2 times 3 times 3, right? Prime factorization. Okay. 90 is what? 2 times 3 times 3 times 5. Is that right? No. 10. Yeah, that's right. Okay. GCF, what do they have in common? They both have 2 3s and a 2. So they have 2 times 3 times 3, that's 18, right? So that appears to be the factor. And if I simplify this, I get 1/5. Okay, I think 1/5. Okay. But watch, you're like, great, I got the answer. I'm gonna enter that. This class is gonna be a breeze. I can get every answer for every problem. Well, no, because what help me solve this is gonna do is gonna reset the problem, and you have to do the same exact problem from scratch. Okay. Okay. So notice I'm still on the same question, but now I have a new problem. That's because I did help me solve this. If I do it again, watch what happens. Okay. 8 over 24. 8 is 2 times 2 times 2. 24 is 2 times 2 times 2 times 3. Ooh. Okay. And then what do they have in common? They both have an 8. Okay. And if I simplify that, I get 1/3. Okay. Same thing's gonna happen. I used help me solve this. I close it, I'm gonna get a new problem. Okay. Okay. So this one, you might notice it was the first one, so you already know it, but whatever. But that's the difference between using those, okay? So what I want to do in this video is just go through with you guys some of these problems. So you already saw sort of how to do this one, right? There's several options. So let's see. Let's see. And I don't want to always make you guys do all the steps. In the help, they said break it down into prime factorizations. Now you might ask, well, how did I know? Like me personally, how did I know that 18 was 2 times 3 times 3? Well, you do something called a factor tree, and we can do them for both numbers. Okay. Factor tree is breaking things down by pairs, and there's really you trial and error, or you can use a calculator to do it. So what 2 numbers multiply to 18? Well, there's 1 and 18. That won't help us. We have to break this 18 down. We still have 18 left. 2 and 9 or 3 and 6. It doesn't matter which you pick. Let's say we wanted to say 18 is 3 and 6. When do we stop? When do we keep going? When the numbers are prime, right? Primes are 2, 3, 5, 7. You can look up a list, but it's a number that isn't divisible by any number besides 1 and itself. Once we hit a prime, we stop and we circle it. Say, okay, we got 3. We don't factor that anymore. We don't draw lines from that. We got 6. 6 is not a prime, right? It's not 5 or 7. What two numbers multiply to 6? 2 and 3. Okay, and those are both primes. We circle them and we keep them. Makes sense, hopefully. So that's how we get 18 is equal to 2 times 3 times 3. Right, 2, 3, and 3. Okay, and we could break 90 down the same way. What two obvious numbers multiply to 90? 9 and 10. Okay, are either of these primes? No. Any even number besides 2 is not a prime, so 10 is 2 and 5. Done, circle them. Those are both primes. 9 is what times what? 3 times 3. So we get 90 is 2 times 3 times 3 times 5. And then we rewrite this fraction, if you like canceling things, as 18, but written in its prime factorization form. 2 times 3 times 3. Over 90, 2 times 3 times 3 times 5. And canceling is kind of fun because you say, oh, I see a 2 here and a 2 here. Cancel them one at a time. 3 here, 3 here. They cancel. 3 here, 3 here. Now I don't put a 0 if there's nothing left. I put a 1 because we can't just get rid of it. So it's 1 over 5. That's the answer. Okay. All right. So that's kind of how you do this. And I do want to encourage you guys to do prime factorizations in the course. It's going to help you a lot. If you want to know, why do you maybe struggle with algebra? It's usually because what I've written right here. You don't have good skills with numbers. You don't have good skills multiplying, dividing, adding, subtracting numbers, seeing patterns in numbers, seeing numbers within numbers. And if you can't do that, algebra becomes hard because you don't have that number sense. Okay. Now, one other feature in Pearson, MyLab Math, is you can do as many attempts on these and as many similar questions as you want. So let's say you got 1/5, but you're unsure and you want to make sure you get it. Well, hit similar question and do this problem instead. Okay. Okay, so it's going to ask me when I leave here if I want to keep this score. I'm going to save my best. Always save best score. Okay, another problem. Okay, let's walk through this one. Now, I'm not going to do all the homework problems, guys, but the goal is to help you somewhere along the way where you may be stuck without watching this. So a lot going on here, and we're kind of jumping head first into algebra. And since this is for an in-person class, you guys are going to see like many examples before this, but wanted to make these to help with homework. So what's going on here? What does this dot mean? What is that dot? That's multiplying, which means we can combine them into one fraction. So we can write it like this. 7 times 8. And this might seem strange, but we're allowed to do this because they're two fractions multiplied. Now, what's our goal here? Do we want to multiply across and bottom? We could, right? We know that 7 times 8 is 56. We know that 4 times 35, if we don't know, we can use a calculator, we can write it out. Say 35 times 4, what is that? 20 to 140. We get that. But if I enter this answer, let's try it. 56 over 140. What do you think the computer is going to say? Let's say I'm wrong. Although your answer, and get used to seeing that because it's a little frustrating when MyLab Math tells us that, although your answer is equal, so it's basically saying, although your answer is right, it's not in the right form, okay? What were the instructions given to us that we didn't follow? Well, let's read it carefully. Type an integer. This integer is just a number, right? These are fractions. Well, we typed a fraction, but it wasn't simplified. So the key word we missed was simplified. So what does it want us to do? It wants us to cancel. So right, if we want to work from here where we just got, and we know we're canceling, that means we're writing things in a prime factorization form. And that means we have to do a factor tree Okay, so um, there's quite a bit of work because these numbers are now a little bigger. Okay, so let's leave that one up. But if I break 56 down, it's a big number. And that means there's work. 7 times 8, well, that's what we have. So that sort of tells us we shouldn't have jumped by multiplying. So having left it in this form was easier than writing it multiplied out. But anyways, 7's a prime, 8 is 2 times 4, and then 4 is 2 times 2. So we know it's right over here, 7 times 2 times 2 times 2. That might look clunky and a lot that's going on there. There's a lot of parts, but we want that because we want to do what? We want to cancel. Okay, 4. So all I did really was I left 7 as a prime, or 8 is 2 times 2 times 2. So what's 4? We don't even have to write a factor tree. 4 is 2 times 2. We already see those 2's are going to cancel. 35, if you know that 35 is what times what, 5 times 7, you don't have to do a factor tree. So you might say, well, why the factor tree? The more you use it, or the more you utilize that algorithm or practice, the more familiar you're going to become with these numbers. You're not going to have to do it after a while. You're going to know. I mean, you might not know 56 is 7 times 2 times 2 times 2. But if you do these enough, you'll know at least that 56 is 7 times 8. And if you know 7 times 8 is 56, you probably know 8 is 2 times 2 times 2. So on. Okay, so once we have it in this form, we see, okay, this answer was right, but we could have canceled a 2, 2 with these 2's, and a 7 with this 7, and we would be left with 2/5. So this giant number was much, much smaller. That's all it's telling us. Okay. So 2/5. Okay. And I don't want to put 40% or 0.4 because it says fraction. Okay. So we got the answer right. Good. Clear my screen. I am having a mouse issue, by the way, with clicking. Sorry, guys. I can get it fixed soon. I'll take it to tech support. But anyways, let's do another one. And then I'll kind of jump around. And like I said, these videos are meant to help. But notice these also have help with them. So, you know, anyways, 5/8 divided. Okay. So what you should be familiar with dividing by a fraction. So it's not the same as multiplication. That should be obvious because then they'd be the same symbol. When we divide by the fraction, what's the phrase or acronym or it's keep, change, flip. Okay, meaning you keep this 5/8. So if we're applying this to dividing by a fraction, and you may have also heard dividing by a fraction is the same as multiplying by the reciprocal. So we keep the 5/8. That's what keep means. Change what? Change this to times. Okay, we don't want to use this too much because that looks like the x, so we're using variables in the course. Flip what? We flip this. So instead of 1/16, it's 16/1, right? And when we multiply two fractions, again, people struggle with this. We multiply across, right? So it's 5 times 16, 8 times 1. We don't cross multiply here, any of that stuff. It's just 5 times 16, which is 80. 8 times 1 is 8. Now, again, I just want to point this out because you'll save yourself some frustration with these problems. You should see already what's going to happen. If I put 80/8, I did the right math. It is a fraction. It's going to tell me I'm wrong. Although your answer is equal to the correct answer. Okay, that means we're on the right track. But 80/8 could be simplified. Why? We could break this down, right? We could just write this as a prime factorization tree. No need. 80, we know 80 is 8 times 10. Now, I don't have to break it down further because I have an 8 here. And the 8's cancel. And I'm left with 10/1, which is really just 10. So the answer is, for this one, is 10. Okay. Okay. Got it. Now, let's bounce around a little. I know these look like a lot, but some of them won't take you too much time. Okay. LCD, it's tough. Let's do one of those and then maybe one more, and we'll jump into another section. 1/2, 7/10. What's the LCD? Well, what's the least common denominator between 1/2 and 7/10? So we're really being asked about what? The numerators, which are the things on top, or the denominators? It's the denominators, right? So because D in LCD stands for denominator. So if we wanted to add, or you might be saying, why do we care? If we want to add or subtract these together, which can occur in real life, we would need them to have the same denominator. So what we can't do, if we wanted to add these, um, adding the numerators is right. 1 plus 7 is 8. But if we added this, so this is the wrong way. If you add the denominators, you get 12, and this is not right. Okay, it's not 8/12. In order to add two fractions, they have to have the same number in the denominator. So let's try this again. Okay, let's do 1/2 plus 7/10. So this problem is just asking what would the same denominator be? That's the least number. There's several ways to do this, and I'll show you a really basic way, but it's pretty awesome. You would write out this one and add multiples of itself. 10 plus itself 20 plus itself 30. We'll go to 5 plus itself 40 plus itself 50. And then we'll do the same with 2. It's going to take a while, but we do 2 plus itself is 4 plus itself is 6 plus itself is 8, 10. Once we have a number that matches in both columns, 10 and 10, that's the LCD. That's just the first half of this problem. We know that this has a 10, so this one's good. We leave it alone. It has the LCD. And they won't always start with one of them having the right one. I'll show you an example. But we know that this half has to have a 10 denominator. And to get the 10 there, we have to use multiplication. We could multiply by 5 in the denominator. That would give us 10. But if we multiply the bottom by 5, we have to multiply the top by 5. So this would give us 5/10. And you can see that 5/10 is a half. These are the same thing. And if we add that to 7/10, we would get 12/10. So the LCD is 10, okay? So that's that. Any other ones here? And there's so much in here. So that's how you would do this problem, right? You would use, so this problem should say, find the LCD and then add them. You have to know what the LCD is. So if we do the same process, we'd write out the 9, add another 9, add another 9, and maybe stop at the 4th. Okay, we're hoping we got it by this one. 3 out of 3, 6 out of 3, 9, and we see that 9's the LCD. 9 here, 9 there. Okay, now I could keep going. I could go 12, 15, 18. And I could do them both over 18, but then I'd have to change this one by multiplying the top and bottom by 2, and this one multiplying the top and bottom by 6. So least stands for the least of these. So 18 is a common denominator, but it's not the least. 9 is. So this one, 7/9, already has a 9. I leave it alone. 1/3 needs a 9. It has a 3. So what would I multiply this 3 by to get 9? It's 3. So top and bottom by 3. I get 3/9, and plus 7/9 is 10/9, and that's the answer. Okay, cool. So again, though, if you're struggling with this, let's say this happens, you're like, okay, I tried it twice, I got it wrong, but on the third try, I got it right. 10/9, enter. Don't go to the next problem. Try it again. The sooner you start doing this, the better the course will be, because you're going to say, oh, wait, okay, my answer was right, but I have no idea how I got that, or I'm unsure. Go to similar question, do it again, do a different problem. Okay. All right. I'll kind of bounce it around here. Say best score. Okay, a completely different problem. And this is just review, guys, so that's why I'm not really like teaching this, and I also teach in class. So how do we do this? Well, here's my take, right? I would point out a few things, and maybe not everyone would, but I'm pretty thorough, at least in introductory algebra. In order to do this problem, 2/5, you kind of have to know what's going on when you have a number up here. What would happen if I put a 0 up here? Well, it's a fact, right? Anything to the 0th power is just 1. So this is just 1. Weird, whatever. So that's sort of like a special thing. Let's star that. How would you do this one? What's 2/5 to the 1, the first power? Just 2/5, right? You don't do anything to it. Finally, we're getting somewhere. So on the third iteration of this, we say, what's 2/5 squared? What does that mean? There's several ways to look at it, but when you have something squared, a squared, that means it's the thing times itself, a times a. So even though it's a fraction, we treat it the same way. I'm going to show you another thing though. That's why algebra is really nice. We could say it's this, 2/5 times 2/5, multiply across, multiply across the bottom. Get that. That's the answer for 2/5 squared. 2/5 cubed, you would do the same thing. So it would be 2/5 times 2/5 times 2/5. 2 times 2 times 2 is 8. 5 times 5 times 5 is big, but it's 125. And that's the answer. But I want to show you a different way because algebra is really rules at the end of the day. And the sooner you understand how the rules dictate everything, really, the easier it becomes. So let me go back here. Go back to this problem. Look at this. Right? Could you think of another way we could have solved that? Because that's not the only way. We don't have to write the thing out twice. And there is, right? In fact, it's simpler. When you have an exponent outside of a parenthesis, and for a fraction, that exponent comes into that. So it's 2 squared. Same thing happens for the 5, right? It's 2 squared over 5 squared. So this squared squares both of these numbers. And the reason this is a little easier is because we know 2 squared is 4. We know 5 squared is 25. Okay? So in fact, we could have done the same thing for this question. Look at this. 2/5 cubed is what cubed over what cubed? It's 2 cubed over 5 cubed, which we know 2 cubed is 8, and we may know 5 cubed is 120. And so alternative way to solve this. Yes, let's see. I'm still in pencil mode. I'm like dabbing the screen. You want to click the screen, not dab it. Okay, question 10. Yeah. Order of operations, right? These are all really good problems, and just showing you guys like some things that will help. Well, I would say this. If I was, learning algebra, especially if I'm struggle with it, first thing, recognize this is just really numbers. So we have to kind of be good with adding, subtracting, multiplying. Okay. But what's going on here with order of operations? Well, in order to really illustrate it, think about how, if you know the right answer to this, think about how a student could misinterpret what's being asked or the procedure and get the wrong answer. Well, what could happen? Think of a wrong answer here. Well, they could do this, right? And you guys kind of know by now it's not the right way, but you could add 8, 5, get 13, and then multiply by 4 to get 52, and that's the wrong answer. Okay. That's probably the only way you do it wrongly. So order of operations stands for or means PEMDAS, right? There's an acronym PEMDAS. And the letters starting from the left take precedence over anything to the right. So P stands for parentheses, E for exponents, M for multiplication, D for division, A for addition, S for subtraction, meaning anything to the left should happen before anything to the right. So I see here I have addition and I have multiplication. Well, multiplication's here, addition's here. So multiplication's for the left. I start with that first. So I should multiply first and get 5 times 4 is 20. Then I add the 8 and I get 28. Okay. That's how you do that. Okay, so that's a good problem. Clear the drawings. Okay. Another sort of order of operations. Here we don't have parentheses, but we do have exponents. Okay, so remember PEMDAS, PEMDAS. P is the biggest one. Anything in parentheses has to happen first. Then exponents. So exponents comes before addition. Exponent cubed. Okay, we have to do 8 cubed first. You could do it in a calculator, but I would do it this way. I'd say this is 8 squared times 8. 8 squared is 64. 64 times 8. How do I do that? Practice. Write these out by hand. Don't just start to use the calculator. What's 8 times 4? 32. Carry the 3. What's 8 times 6 plus 3? 51. 512. Now that's not the final answer. So if you do this, think about this. Why would this be wrong? I did this math. I'm not thinking. I'm trying to rush through this. I get it wrong. Why? What did we do? All we did was the 8 cubed part, right? We only cubed 8. Well, what else was included in this equation or expression? Adding 2. So once we got that 512, we have to add 2 to it and get 514. Okay, yeah, that's how you do it. So the right answer was 514. Okay. And I think I'll do one more because I don't want these videos to be too long. I'm only meant to help a little bit. And here's a hard problem. This one's not easy. Why? Because there's a lot going on. And I don't want you guys to be able to do up to this point and not do the actual problem. Now, I do have a way, I guess a method that I think can help here. And this is something you should sort of learn as we go through this course. And my guess is for a lot of you, you could do part of this problem, but not the whole problem, right? So think about this is really multiple problems in one. So one of the problems you could see is, could I do 5 squared? I think everyone can do 5 squared. That's 25, right? So you could rewrite that and say this is really 28 minus 25 over 2 times 25, and then maybe you get that. Or you can approach the problem as 2 parts, right? This is one part, this is another part. Let me do this. Let me solve the top part. The top part says do 28 minus 5 squared. Well, that's 28 minus 25, which is 3. Okay, I could do half the problem. Oh, guess what? I can do the other half. But for some reason, when I have to do the whole problem, I can't solve it. 2 times 5 squared, that's 2 times 25, that's 50. So I was able to do both halves. Why can't I do the whole? Because you're trying to do everything at once. So the answer would be what? 3 over 50. It's the top over the bottom. That's it. So a good rule of thumb or practice to try, especially on things where you kind of see and know that you can do some of the problem, but you can't put the whole thing together. Break it down into components in simpler parts and try to solve those and then see how you get the whole answer. Okay. Okay. All right. I think that's it, guys. I could go on and on. But we will be going more in depth in the other videos. So this is just how to do this one. So if you enjoyed the video, please let me know. And that's it.